In this second page of the Graphing Sinusoidal Functions notes, we're going to start with the graph and learn how to write an equation for the graph. So on the notes, I have kind of a set of steps that I think through when I'm trying to find things. So I'm not going to read those for you. I'm just going to go through the examples, but you can go back and read those later. Okay, so let's write a cosine equation for this graph. There's two things I always do to start with, and one is to identify a cosine cycle. Since cosine starts high and ends high, this would be a cosine cycle right here. I also want to identify the sinusoidal axis. Since the high point is 8 and the low point is -12, there's 20 units between those. So from the high point to the middle would be 10 units, and from the middle to the low point, I realize you're not seeing what I'm doing here, 8 to -12 is 20 units. The high point to the middle is 10 units, which gets us to -2, and from -2 to -12 is 10 more units. So the halfway point is this -2, which I have so providentially labeled for you. Okay? But if I had not labeled that -2, you could still figure it out by finding the halfway point between the high point and the low point. So sinusoidal axis is -2. The amplitude is the distance from the sinusoidal axis up to the high point, so the amplitude is 10. The period is from the distance it takes to complete one cycle, and we go from -100 to +20, so this is 120 units. So the period is equal to 120. The phase displacement is the starting point of a cycle, and we could say the phase displacement is -100. We could also say 20. So it's the start is x equals -100 or x equals 20. And actually there could be other starting points of a cycle too if we continued farther to the right or to the left. So our equation is y equals a cosine b times x minus d plus c. Well, sinusoidal axis is -2. Amplitude is 10. Phase displacement is -100 or 20. The question is b. b isn't 120. b is related to 120. Recall that the period is equal to 2 pi divided by b. We could also say that b is 2 pi divided by the period. So b is equal to 2 pi over 120 or pi over 60. So that is our b value. So finally writing the entire equation, y equals 10 cosine times pi over 60. Now, when I say x, that d is -100, that means I'm saying x minus the -100 or x plus 100 to shift it to the left 100. Or I could say x minus 20 to shift it to the right. Either one of those is a correct equation. Now, what if I wanted to write a sine equation for the same function? I'm going to draw this in a different color so we can see it more clearly. A sine equation has to start on the sinusoidal axis, go up, back down, and then end on the sinusoidal axis. So here's our sinusoidal equation. I also told you that the points on the sinusoidal axis are halfway between the high point and the low point as far as their x location. So if this point is 20 and this point is -40, the point where the graph crosses on the sinusoidal axis is halfway between. Since this is a distance of 60 from -40 to 20, from -40 to this point here is going to be 30 units, or this would be -10. -10 to 20 is 30 units. Same thing here for this point in the sinusoidal axis. It's going to be halfway in between 20 and 80, which would be at 50. And then, so if I'm dividing this up into increments of 30, this would be 80, the next one would be 110. So I do this to illustrate that one cycle of a sine graph from -10 to 110 is exactly the same as one cycle, one period of a cosine graph. It's still 120 units. The sinusoidal axis is the same. The amplitude is the same. In fact, the only number that changes when we change from sine to cosine is the starting point. So I'm going to write y equals 10 sine of pi over 60 times, leave that open, minus 2. So where is the starting point? Right here, -10. So what goes in here, I'm going to change this to green, is x plus 10. So this is the only thing that changes for a sine graph as opposed to a cosine graph. Now I want to stop for a moment and let's graph these just to show you that there are 3 different ways we wrote this equation and they're all the same equation. Okay, I want to point out that I've already typed in the equation. Notice the use of parentheses. This is very important. The x minus 60, the pi minus 60 is inside the cosine function inside parentheses, and within that parentheses is another set of parentheses for the x plus 100. If you are not careful with your parentheses, you will not get the correct graph. Now I want to make, if I go ahead and graph this, my window settings aren't at all what I want. So I want to show you a quick way to change your window settings. If you double click on any of the end points of the graph, the numbers, I want to make my window settings to match the picture in the book. So it goes from -12 to 8. So let's make this maybe about 10. If you push tab, it automatically jumps over to here. This was about 110. The graph ended at 110, so I'm going to make it about 120. Down here, the negative was -12, so maybe make it -14. And then the last one was about -100, so maybe -120. Okay, so that should look like what I've got here. I can trace the graph. Let's kind of get this out of the way. If I push menu and trace and graph trace, now if I want to check for my key points, I can type in, for example, -100, which is one of my x values, and it'll tell me the y value. So at -100, I should be at 8. That looks right. If I type in -10, for example, that is a low point. That's at -2. I'm sorry, -10 was at the sinusoidal axis, -2. A low point was at -40. So -40 is a low point. There's where I'm at -12. So you can check to see if your graph is accurate. Now by hitting tab, I can open up another equation. So let me show you that if I change, or actually let me just show you that if I change the plus 100 to a -20, it doesn't change anything. Same graph, okay? Now let's go up, and if I change this to a plus 10 and change cosine to sine, so this is plus 10, and change the cosine to sine, same graph. Okay, nothing changes. They're all the same. They're all the equation of the same graph. So when you do these kinds of problems, there are multiple ways to get the correct answer. Okay, so let's go back to the notes. That's not the notes I was on. All right, and let's look at the next section of the notes. So how could we write both a cosine and a sine graph for the following graph? I want you to pause the video and try this yourself, and then I'll reveal the answer. Of course, I'm having trouble pausing my video here. Okay, never mind. I'm not going to pause my video. Well, maybe you've already paused. I'm going to just go through this quickly. It looks like my sinusoidal axis is at -2. My amplitude is 1. So I've got y is equal to 1 cosine of, put all this stuff in the middle, -2. My cosine cycle would be from here to here. It looks like the period here is 16. So the period is equal to 2 pi over b, or the period, or the b is equal to 2 pi over 16, which is pi over 8. So pi over 8 goes in here. Then I just need a starting point. I start at negative 10, so this could be x plus 10. Or I could say that I start at 6, so this would be x minus 6. The sine cycle would start here and end here, going up and then down and then back up again. So the only thing that would be different is where the starting point is. It looks like that would, our critical points are all 4 away from each other, so this would be negative 14 here. So the only difference in the equation would be this is y equals cosine pi over 8 times x plus 14 minus 2. Now, what if I said write an equation for which the phase displacement, or the starting point, is negative 6? So in other words, what if I wanted to start a cycle right here? Well, this would be one cycle right here. It's like a sine, except it's upside down. So the way I could write an equation for that is to say y is equal to negative sine pi over 8 times x plus 6 minus 2. This turns the cycle upside down, and so I could have a starting point of 6. Now, what about for which the phase displacement is negative 2? Let me get a different color here. So we're saying, what if I wanted to start here where x is negative 2? Well, this would be an upside down cosine cycle. So I would do the same thing, only I would say y is equal to negative cosine pi over 8 times x plus 2 minus 2. So I can use any point, any one of my critical points to be a starting point of the cycle. You have to recognize whether it's cosine or sine, and whether it's right side up or upside down. Last piece of information that I want to share with you is some vocabulary about the shape of the graph. We define concave up as being this shape, and concave down as being this shape. So an easy way to remember it is that concave up is a cup, maybe a cup of hot tea on a cold day like this. So concave up is a cup. Concave down is a frown. So if you remember, concave up is a cup, concave down is a frown. We can identify sections of the graph that are concave up and down. So all these red values are all concave down. So these sections of the graph are all concave down. These blue sections of the graph here are all concave up. Now the point of inflection is the point at which the curve changes from concave up to concave down, or vice versa. So this, all these black points are all points of inflection. In other words, where does the graph change from being concave down to being concave up? And it turns out that these points are significant in that the slope of the graph at the points of inflection is at a maximum. So think about here, if we were thinking about the slope of this graph, it's fairly steep, but then as we get to the top, the slope gets less steep. You could think of it as, so let me kind of just draw another thing here. So here would be the slope here, pretty steep, a little less steep. The slope is 0 here. Now the slope gets a little bit more, this is steeper in the negative direction, a little more steep. Now it's getting less steep. Now it's 0. Well, the point of inflection is the point at the maximum amount of steepness of the slope, or the maximum rate of change. And that's a really important concept in calculus, and a point that we'll be talking about more later. But I just wanted to give you that vocabulary so you would recognize concave up, concave down, and points of inflection.